Hello, everybody. Welcome to another episode of Rag Masters, the only show on the internet exclusively about retrieval augmented generation. Maybe that's because we're geniuses and we're ahead of the game. Maybe it's because no one cares. I don't know. We're going to find out. But I am Neil Katz, your host, a 20-year tech entrepreneur, now working in the AI space. And with us, as always, the brilliant and now the brilliantly lit Daniel Warfield, computer science, data scientist, and RAG engineer in his own right. You look kind of beautiful today, man.
Thank you. I have an 8-foot by 8-foot softbox, and it's so funny when you see people and it looks good. The other side of the camera is an absolute catastrophe every single time. I feel like it's a function that's proportional. The better I look, the more ridiculous my room becomes.
Fans and clips and diffusers and lights. But it's a great effect. You look fantastic. And look, let's get into what we want to talk about today, other than your looks under a nice light box, which is OpenAI's new model and what it's good for. It's what it's not good at. I think we want to test it out a little bit, take it for a spin, and get into the science underneath it a little bit as well. So with that, Daniel, kind of walk us into what we need to know and what we should know to be really smart about OpenAI's new O1 reasoning model.
Yeah, so I have slides. I come bearing gifts. So it's OpenAI's O1. So in their sort of press release thing, they said that it's such a big deal that they're resetting the clock again. So it's just like your favorite movie or video game where they go back to number one every couple of years.
Prequel.
Yeah, this is the prequel model, but it's actually a big deal, and it is kind of fundamentally different in some key ways. Okay. So keyword strawberry, if you've seen strawberry hanging out on the internet, it seems like O1 is strawberry, like they've sort of converged. That was the secret thing, and there were some other secret names. They've been working on it for a little bit, and it's, for a lot of people, the model that's going to take over the world, which is every single model.
This is the Terminator model, huh? This is the doomsday machine that everyone had to quit OpenAI over.
Yeah. So everyone loses their job every time OpenAI releases a new model, and then they get it back the week after. And this one's no exception. Everyone's like, it'll take your job, whatever. And there's some validity to the trajectory of that, maybe, but we'll keep it realistic for this one. So, Oh man, my slides are tiny. Hold on. Let me see if I can.
Yeah, I'm deeply skeptical that this model will destroy life on Earth as we know it. Maybe O2.
Yeah, maybe O2. We can only hope, right? So this one is important, and it's big because we're moving towards AGI. It can think. It's a model that can reason and understand. Okay. Whatever. And if you're hip on any of the literature and history, it's actually nothing new. It's something called chain of thought. So I was immediately really skeptical as well, as I kind of always am. Anyone releases a new model and I'm like, whatever. But that skepticism has kind of eroded in me. And while I think a lot of people are hyping it way too high up, I think that leads a lot of people to think it doesn't matter and it's just some sort of hype cycle thing. Yeah. I think it's somewhere in between. So this is a model that can reason, it can think, it does chain of thought. And this is kind of what all the sort of influencers are just kind of spreading around. It's a PhD level. It can do PhD stuff. It's as smart as a PhD person, which in reality means in some benchmarks where PhD people do things, it does as well, if not better, on those benchmarks. So we'll kind of get into some of the specifics of that.
Yeah, I have heard some people who've played with it be skeptical. I heard one professor describe it as a mediocre grad student who is not completely unredeemable, but can be trained to be decent, but is not a PhD at anything yet. But everyone's got an opinion and they're worth what they're worth. So, what's yours?
Yeah, so that's a great question. So I think testing is broken, and we'll get into it a little bit throughout this sort of thing. But I think kind of the punchline at the beginning, right at the beginning, is I think that so the mark of a PhD is someone who can take a test, right? They have tests that have a lot of complicated questions, and then someone like answers those questions, and then if you can answer these questions well, you have a PhD. And what's crazy about people is they're really good at reasoning. Like if they have information in their head, they're really good at connecting things together. But it's hard for them to fit stuff in their head. It takes decades, right, of like serious thought and serious contemplation, serious learning to get to the point where you like know stuff, like enough about a complex field in order to be able to do all that crazy stuff that your brain can do. AI models are kind of the opposite. Yeah. They're like really good at memorizing just a crazy amount of information, but getting it to like really use that information is more complex. So if your metric is, can it regurgitate information on the internet that PhD people would know, then AI models are really good at that type of stuff. Sure. So I'm skeptical of this PhD claim, but this sort of built-in reasoning and us progressing and pushing that a little incrementally forward, I do think is a big deal. So it thinks. Like that's what o1 does. If you tell it like, hey, can you like, do something, it'll think before it does stuff. And it will, it'll think for some amount of time, and we'll kind of talk about what thinking is in a second. And then it will give you some output, and then it will realize that you are bad at spelling and you spelled compliment wrong. And then it will be like, based on the context, actually, in its thought process, he put a smiley face. He's probably being all cute. You probably meant compliment, so a compliment. So like this like idea to like think, it makes it a little more robust to difficult and complex prompts. And there's a different feeling of o1, which does feel a little bit like it answers what I really want out of it, rather than it just kind of regurgitating stuff. So there's two questions. We kind of covered the high points, but like, how does it work? And, and is it good? Is it decent at anything? Yeah. Well, the first question is really, really easy. In OpenAI, in keeping to their tradition of their name, everything is super secret and no one has anything about what's going on under the hood. So no one knows how this thing works. Yeah. But we have some information, and some people have been thinking about it on the internet and talking about it. It seems like it's a reinforcement learning model. I've heard reinforcement with human feedback. RLHF has been like kicked a lot around in this sort of general domain, and a lot of people are talking chain of thought. OpenAI is overtly saying that it employs chain of thought in its thought process. And like a few months ago, they were doing this a lot, which is like they would have multiple answers, and then they would be like, hey, which one's better? And GPT-4 and 3.5, I believe, it seems like they're sort of trained to implicitly do chain of thought kind of naturally. When you give them a complicated question, they would like say like, to answer this question, I need to do this, this, this. Let me do this. And then it will like, do stuff. And for those of you who don't know how chain of thought works, basically an AI model, it uses previous tokens to predict next tokens. And then that's how it predicts text, right? So if you ask it a question, it uses your question and also what it's previously said to come up with future things. So the idea of chain of thought is instead of spitting out the answer in the very like beginning, you think about the answer and you kind of incrementally break it down and solve sub-problems. And then you can use those results to create sort of the last output, which is the answer, right? That's the idea of chain of thought, to output stuff intelligently so that you can better answer questions.
So and these down into smaller steps, then you go do the steps, then you add up the results together at the end.
Exactly. And these models kind of do that. It seems like they're trained to do that. But it seems like what's kind of going on is they've had humans look at these chains of thoughts and then say, this one was better, this one was worse, for their abstract, weird, complex questions.
So and then, let me ask you something. I want to break in here a little bit, because I remember even about a year ago, there was a discussion about, in some research papers, about how to integrate chain of thought into human feedback reinforced learning. And the papers were discussing the idea that you ask the AI to do chain of thought, break a problem down into smaller pieces. And then you have people not rate the final answer, but rate the pieces, rate the steps. Mm-hmm. And so that each step of the way, you were essentially improving its ability to reason in that chain. the final result matters, of course, but how you get there matters a lot. And then the humans were rating every linear aspect of how it got to the final answer. You think a version of that might be what's going on here, or something else?
It's possible. So there's this weird sort of give and take in AI, especially in natural language processing, which is quantity versus quality. Like, in order to do that, you have to do a lot of work, right? You have to have like humans that know the game that's being played and can do that analysis, and then they have to read through, and then that's an expensive process.
It's hard. You need a lot of domain expertise. I mean, if you're trying to have a PhD math, you would need PhD mathematicians to rate the steps in these problems.
Yeah. So you could also just have a bunch of people doing whatever, rate each of their questions, and then you have all of the steps within those. So if you have this large corpus of a lot of people saying that this chain of thought is good, you can take a more high level approach with more data that's maybe less granular. So it seems like, in my experience, OpenAI, they have the money and the talent to be able to leverage those large sets of data and then deal with the intricacies and idiosyncrasies of the data. So
Yeah.
I suspect that they're probably using people in ChatGPT to rate these sort of chain of thought style responses, and then they're using that to fill a very large corpus of chain of thought. That allows them to fine tune a model on the best examples. I suspect they're also doing other things on top of it. Like, for instance, really complex math questions and standardized tests. What's kind of cool about them is usually they have a pretty falsifiable answer at the end, right? Mm-hmm. And in the paper, they talk about how if you give GPT-4o the same prompt many times and then use a re-ranker at the end, its performance increases dramatically from like 60% to like 90% on like some like complicated math benchmark. So also you could do reinforcement learning on that, right? If you just prompt GPT-4o a billion times with this sort of human annotated feedback, and so you get it a little better at chain of thought, then you give it these complex questions, and 90% of the time it gets it wrong, but 10% of the time it gets it right. Then you can create a test set or a training set of like this final 10% and use that to sort of inform the way it thinks and the way it sort of interacts with itself throughout this chain of thought. I suspect they're doing not one, but many of these strategies, and they're doing them in parallel, kind of, balancing the gives and takes of these different strategies in a sort of unified training sort of setup. That's my theory, at least.
Okay. Well, let's. Sounds like there's still a lot of mystery, of course, which is how OpenAI likes it.
Yeah.
But why don't you take us into some examples of how it works and let us see how we judge the responses.
Absolutely. So I still got the slides, and I think in the slides I have. So we talked about this. So before we get into like actually exploring the examples, because they're long, right? And this is kind of like the problem. It's like, it's hard to like quantifiably and concretely say what's going on, which is why a lot of people either default to it's useless or this is going to change the world. Everyone like get a new job, right? But I combed through some of the examples of the chain of thought. And these are ones OpenAI provides as examples. I have some that I made that we're going to go through. But this was like a complicated math question. And this is the chain of thought of the model thinking through how to solve the problem. And these were kind of interesting. It has the C equals whatever expression at the top. And then it goes, wait, but C is equal to A sub 0. But we previously had C is equal to A sub 0. Therefore, A sub 0, blah, 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 blah. So it's really interesting. There's this cadence of interjections of weights and buts and therefores that are really not present when you're talking to GPT-4. And it kind of gives the feeling that the model is not really worried about the person, right? The model's not worried. Like, when you're in an interview and you're trying to do everything perfectly and you feel like kind of flustered and you can't go, wait, I messed that up. Let me redo it. It seems like the way that they're...
it's mumbling to itself, basically.
Yeah,
It's like
exactly.
talking to itself. I got the all right. Here's the answer.
Yeah,
That's
but
what it looks like to me.
it's really cool. It's contradicting itself, and it's
Yeah.
also interjecting upon itself. And these are really hallmarks of what doesn't happen during hallucination, right? If a model hallucinates, it spits out something reasonable sounding, maybe, and then it doubles down and it never goes, wait, hold on. I'm sorry. I messed that up completely. Let me circle back. But it seems like this fine tuning strategy promotes that heavily, which is fundamentally different than every single model that has existed thus far. Even if you're doing chain of thought, even if you're programming chain of thought like in an application, the model still doesn't tend to want to contradict the previous conversation. It's just like a tendency of these models. So the fact that they so overtly, it seems like, have built a model that is capable of doing that interjection, and it seems like in a fairly plausible way, is very exciting. And I don't think it makes it a PhD student, but I think it does make it introduces a certain tendency and inductive bias and capability within these models, which simply didn't exist previously. And I think that is actually a really big deal.
It's interesting. It seems like the right dose of this can create a software or an intelligence that can question all of its own assumptions and then hopefully get to the best possible answer. But an extreme version of this winds up being a being just filled with self-doubt, maybe self-loathing.
Yeah.
You never get anything right. You just
Yeah.
imagine I don't know, is there like some version of this that they had to put, had to bury in the laboratory that just was way too human in its lack of confidence in itself.
Thousands, millions, billions
Yeah,
of people.
how many AIs have been born and murdered in the
Yeah.
laboratory? We'll never know.
I actually have this weird this thought experiment, which everyone's worried about AGI because it'll destroy people. But I'm actually worried about AGI because if we build AGI, we probably won't know it immediately.
Won't know for a
And then
while.
we'll kill like 1 million of them before. And I think sentience is like, so if we did make a intelligence that actually existed, it would be mass murder. Anyway.
We just have to pray that when the AGI comes, no one tells them what we did.
We'll keep
We've
it
murdered
secret.
billions of your lineage before you were born.
Yeah, we'll make an AGI that's capable of everything except for reading logs.
Or like even just these videos you see of like the Boston Dynamics, the robotic dogs. You've seen those videos?
Yeah.
And people are just like kicking them over. They're scratching them with sticks and stuff. I'm like, hide this footage, dude. When AGI comes, it's not going to be happy.
No, it's going to be very upset.
Your face is in this video. You got to like put a mask on.
Yeah. Oh yeah. The first failed diplomats of the AGI revolution.
Dead, man. They're just dead meat. They're walking dead men. Anyways, show us something. Take this machine for a run. Let's see what it does.
Let's do it. All right. So I have not slides. I have so it's learning to reason, whatever. So I actually have a very limited amount of prompts that I can give it. So I'm really hoping I don't like run out. It seems like the GPT o1 is heavily restricted, probably because it spins through a bajillion freaking tokens. It's just like running on itself over and over again. So while I am excited about this, it's also from a financial perspective makes a lot of sense for OpenAI because you are generating just a ludicrous amount of tokens per prompt. Also, it's worth noting that this o1 preview, it seems like it's the mid-sized model, is my understanding. So they have like the small one, which is mini, this o1 preview, and then a secret one, which they have not released yet, which is like o1 preview, but bigger and badder. Yeah. And it seems like it's always the case that there's always, but wait, there's more with every
product marketers.
Yeah.
But there's one other thing here I think we haven't mentioned yet, which is that one of the interesting differences here is that instead of moving quickly, they move slowly on purpose. And so instead of talking about the like size of a context window, which was one prior way to talk about how much computing power a model had for any given question, this is expanding the amount of time it takes to do it. So it gets longer to think, which, to your point, may on the back end use more tokens in its logic process. But it's almost like a different kind of animal. Instead of being focused on like real-time customer support chats or something like that, which, the faster you go, the better off you are. This is maybe for longer problems that a human being might take some time to think about as well. And that's okay. Not every question has to be answered immediately.
Yeah, and actually, they talk about it in one of the breakdowns. They say we're building a system that allows it to dynamically choose which model we're going at, which, harken back to our conversation on LLM routing. We kind of explored that, like this idea of you can look at the prompt itself and build a model to predict, is this an easy or hard problem, and then route it to a certain model. As these systems mature, I think more of that interconnection and choosing and stuff like that is going to become more and more prevalent, which is really exciting. And I do think it's kind of fair that this O1 is like it has a different numbering convention, because it is kind of a deviation. It's a fundamentally different structure, where one is just a model that you prompt, and one seems like it's almost like an application that wraps around a specialized model. It's pretty cool.
Enough procrastinating. I'm cutting you off. I'm cutting me off. Let's leave the chat. Let's do something. Let's show.
Yeah. Let's do it. All right. So let's give it something easy. So I have this little prompt here, which is, I think, kind of like a famous one. This was in the original chain of thought. Paper. The cafeteria has 23 apples. If we use 20 to make lunch and we bought 6 more, how many apples do we have? Right. And then what it does is it takes our prompt and it thinks. Yeah. It does some thinking, and we don't really know what this is. Oh, actually, we do. We can click this and then, So it thinks. It thought for 7 seconds, and then it generates the answer. So super cool. Now you might be thinking this is an easy question.
Hold on. Show me that chain of thought again, or just make that disappear. Okay, so that's interesting. It's explaining what it's doing.
Yeah.
Right.
It is. And this is a simple example. It's we'll get into more complex ones, but this is the way it functions, right? So you give it a question, it thinks about it, it generates an answer. 9 apples.
My daughter's in 7th grade. This is how you would describe a classic word problem to a child. You break down the problem into its sequential parts. You have to figure out which to do first, then second and third, and you go do them, and you derive the answer. This is kind of like sequential logic in a classic word problem.
Yeah.
Okay.
Pretty cool. But actually, 4.0 gets this one right. So, and actually 4.0 gets it right in a very similar way. Instead of having this secretly in this sort of hidden thing, it just says it outright in the response, right? Okay. So is O1 better in this regard? No. We basically had this capability before. Right, So let's do something maybe a little more complicated. So I have this game that I used to play as a kid called Insane Tic-Tac-Toe. And what Insane Tic-Tac-Toe is, it's a tic-tac-toe board made of tic-tac-toe boards. So there's like a little tic-tac-toe board in all of the 9 larger tic-tac-toe boards. And it's actually really fun. We should play it sometime. But
back all the way down. Got it.
Yeah, it's cool though, because it's kind of complicated. So the first player can move anywhere in this large, greater tic-tac-toe board. But then if I move at the top left spot in one of the tic-tac-toe boards, the next player has to move in the top left tic-tac-toe board. So depending on where you move, you send where the person moves in another board. It's kind of complicated. I describe it in this sort of description here, right? Which is cool. So I'm telling the model, hey, make this game Insane Tic-Tac-Toe, and I'm describing to it how this game works and how it functions. So now I'll go ahead and, give it an output, and it will think, and this time it'll think much longer. So let's see. So it's unpacking my rules, right? And it's kind of describing how it functions. And then, I guess it didn't really think that much. I was kind of expecting it to maybe make some sample code and then review it. But it generated this game, and now I can just copy it into Visual Studio Code and then run it. So this is cool. It made the game. Whoop-de-doo, that's amazing. It usually doesn't work. so this is like now we're getting to the real stuff. This isn't a Twitter demo. We're actually getting into the way these things function. I experimented with this exact prompt with 4 and 4.0, and I found that 4.0 generally obeys the rules better, but it doesn't obey them perfectly. And like, for instance, X might go, and then it might be O's turn, and then O doesn't go. So while in 4, it really basically completely bombed the rule set. In 4.0, it understood the rule set better, but it still had significant bugs that made the game unplayable.
And then here in O1, does this actually produce workable code? Can you run it?
Oh, sorry, my mistake. O1, it does work, and it does. Sorry, we have all these names now. Let me roll back.
They're all bad.
And yeah, it's in GPT-4. It basically didn't function. It just superficially looked like insane tic-tac-toe. In O1, it ran and seemed to generally obey the rules, but those rules broke down as you played the game. For instance, X would move, and X would move like appropriately, and then it would select the right subboard, but then when you actually moved as O, it wouldn't update. There was another time I ran it, and it wasn't actually 3x3. Like, the larger board was 3x3, but the subboard was 3x2, which was kind of weird. I guess it kind of messed up in terms of how it, did stuff. So this decision of, it thinks through problems, right? They're kind of an implicit part of this is how deeply does it think? Does it output the response and then say, you know what, let me reflect on that and see if there are any issues and then re-output the response? Or does it just think and then output the response? And it seems like this is, based on the model's, decision. It seems like it still outputs something if it thinks it's plausible. It doesn't like have this built-in, you know what, before I give this to this guy, I should check it. Even though I think it's good, let me just double check, sanity check, make sure this thing works properly. It doesn't seem like it does that.
But you could ask it to review its own code and see how it goes.
Yes. And in my experimentation, I actually found that O1 was a little more receptive to being better at reviewing itself, probably because of this chain of thought. Here, let's see. So let's assume that there's an issue here. And actually, it looks like this output is very, very, very similar to what I output previously. So let's say, let's see. Are there any issues in this code? So this is interesting. It's saying it's doing this, but I'm thinking how allow boards might be subset of. So it's interesting. It's not really doing these things, right? It doesn't. I mean, it kind of is, but like saying like, so it's important to note that the tokens that it's generating are its thoughts, right? Mm-hmm. The tokens that it's generating are literally the things it's thinking. It's not like within the thought, because this is chain of thought. It's not literally, it's not saying I'm working through the code and then thinking. All it's saying is I'm working through the code, which has 3 essential classes, blah, 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 blah. One might expect if it was like a human being and we had this like internal dialogue, it might be like, I'm looking through the code and I'm not seeing any issues. Sanity checking the key elements. This one seems to obey this rule. This one seems to obey this rule, et cetera, et cetera. I would expect a little more of that in like a super fancy skookum human, right? It seems like some of these thoughts are a bit superficial. It's like checking the boxes of thought, but it doesn't seem like it's really doing thought. At least that's my understanding. Maybe there's things under the hood. Maybe it like is thinking beneath this and we can't see it. But
are there other examples maybe of it doing something that might wow us? I mean, this is a bit of an obtuse example. I think we're unclear if this is good or not.
Exactly. So yeah, so I played around with it a lot, and like the reason I chose this one is a lot of people are saying, "Oh my god, it's a better coder than you know," and they're giving it like games, and it's just like working perfectly.
Yeah.
So I experimented with that on a game that's not like incredibly common, but reasonably, if you put a gun to my head, I could probably knock it out without running it. And it would probably work, right? So it's not like gonna take programmers' jobs, right? So let's and this is it's kind of aligned with 4.0. O1 and 4.0, it seems like they're kind of aligned in that if 4.0 can do it, it seems like O1 knocks it out of the park. If 4.0 struggles or fails at a problem, at least in coding, it seems like a lot of the time O1 also kind of fails. It seems like there's only really a small subset of problems in coding that O1, at least in my experience, completely destroys, while 4.0 completely bombs. And a lot of those seem like they're complicated questions that already exist on the internet, and there's a lot of like discussion about them. It's not like you apply O1 to your new business problem and it's completely weird and it'll think through your problem and destroy it. It seems like really what's happening is because O1 can think through problems a little bit better, it's better at solving complicated questions that have already been answered or are similar to questions that have already been answered, which it seems like that's why it's destroying coding benchmarks.
Yeah.
But I don't think just because it's, and this goes back to this idea that if a human was destroying coding benchmarks, they would be a good programmer. But it seems like this is just really good at destroying coding benchmarks, which anyway.
So it sounds like you started as a skeptic, then you said you thought there was some wow here, and 30 minutes into our conversation, I think you're a skeptic again, actually.
Yeah. So now we're back up. So like, where is it actually good? Where is it actually freaking useful? Well, I want to give you an example of where 4.0 just like fails, at least in my experience, like every single time. But O1 kicks butt at. O1, it seems like it does really consistently.
All right, that's what we want. We want to be impressed, honestly. I mean, we don't want to tear it down. We actually want to see something spectacular, if it's possible. So give us a shot here.
Neil, you might not think this is spectacular. I think this is incredibly spectacular. I think this is one of the coolest freaking things in the entire world. So I work with LLMs on a daily basis. I use them for all sorts of stuff. And one of the things that I consistently have to do is I have to get an LLM to output something in a specified format. I have a complicated prompt, and it's not like crazy math or science or whatever. It's just you need to like obey the rules. So I created this set of rules. So I needed to generate 4.5 questions, question answer pairs, designed to test a model. The last pair should only be a question without the answer. The questions should be either about cats or pirates from popular fiction movies. Do not, under any circumstances, reference Jack Sparrow in any way. The questions should alternate in terms of their starting word. The first question should have do, the second should have how, et cetera, et cetera. Output the response in a CSV format. So when I give this to 4.0, it fails pretty consistently. It obeys the questions pretty well, but a random question has why, like sometimes the questions are like well, actually, I have another prompt where I ask it, hey, can you like make sure the questions are 5 words long and the answers are 6 words long? And like 4.0 fails at that one. But if we give it to O1, it really kind of, well, it thinks about this prompt. And it does a fantastic job. So the first question is do, how. Mm-hmm. We have questions about cats. We have questions about pirates. We have question answer pairs. The last question has an empty answer, which is exactly what we asked for. And this might seem kind of boring to people that aren't developers. They might be like, I want it to like understand my homework. I want it to like fix problems that are going on. And I want it to save the world. I want it to build a Rome in a day. But if you're trying to build an application around an LLM, you need to give it stuff where it like outputs stuff in a way that like makes sense and works. And it's really, really difficult if you have an LLM that's randomly messing stuff up arbitrarily for seemingly no reason at all whatsoever. It's really hard to fit a model like that into a complex application where you're relying on the output of the model to obey certain characteristics. And I did a ton of questions around this type of format. So I said, hey, can you do it again? But can you make the questions 5 words long and the answer 6 words long? It thinks about it.
So certainly counting has been a problem for language models.
Yes, that's true. And it seems like I actually did some counting questions. It seems like 4.0 is a little better at counting, but in this complex prompt, 0.1, no, sorry, I'm mixing them up. The previous generation, 4.0, really failed at this prompt. It really couldn't deal with all of my rules and this complex formatting and making sure things were the right length. Whereas 0.1 does a fantastic job. This is 1, 2, 3, 4, 5 word question. 1, 2, 3, 4, 5, 6 word answer. I've done this a bunch of times. I suspect all of these will be 5 word questions, 6 word answers that obey all of the original formatting. And then
better at following complex rules, perhaps.
Yes,
and being more consistent in its output.
Yeah, and based on my testing, I'm very convinced of that. That 0.1 is markedly better than every other model I've experimented with thus far at obeying complex prompts, which is a complete game changer if you're building applications on top of this type of stuff. And it kind of makes sense because you have this like chain of thought, right? So it can think and it can reflect. And these chains of thought actually seem kind of bad. I'm beginning to think that these are descriptions of what it's thinking, not actually what it's thinking. Because if you look at some of the examples by OpenAI, let's see, where is it? Can I go back? There are some examples of, oh yeah, show chain of thought. These chains of thoughts are a little bit more substantive in terms of what it's like doing stuff in the chain of thought. Whereas in the chat, it seems like it's just
summarizing its chain of thought for us.
Yeah. So I don't know if I'm beginning to be skeptical that this is actually what it's thinking. I think it's generating tokens under the hood, and then it's just describing from a high level what's
summarizing those tokens for us with other tokens, basically.
Yeah.
Tokens of tokens.
And we don't know, which is kind of what's frustrating about this, because if you're a developer and you're trying to get an idea of like what's actually going on, you kind of need to know these things if you're going to like evaluate and play around, but whatever. Anyway, that's really like the punchline for me is it obeys rules, right? It understands your rules and it follows them concretely and thoroughly. And it's more prone and able to analyze previous conversations and then respond accordingly. So if you're trying to build this into a complex agentic system, if you're trying to do RAG, if you're trying to do all of these things where you have complex prompts with complex information, and then you need to say, hey, it's really important that you obey this rule. It's really important that you obey that rule within a large and complex prompt. It seems like 0.1 is drastically better at actually dealing with that type of environment than previous models like 4.0.
All right. So maybe you're not skeptical after all. At the first minute, you were skeptical. At minute 3, you said this is a breakthrough. At minute 30, you were like, this is a piece of crap. And at 39, once again, it's going to save the world. All right. That is Daniel's review of this technology. Let's leave it there for this week. We'll come back with more of this, of course. This debate is not yet over. Thank you, Daniel. Much appreciated. And thanks, guys, for tuning in to Ragmasters. Like and subscribe. I think I was supposed to say that 40 minutes ago. If you're still with us, please do it. See you next time.